You know that feeling, right? That little gut feeling when you just know you've got the right answer to something. Well, what if we could teach an AI to have that exact same instinct? Today, we're going to break down an absolutely fascinating new method called LaSeR. It gives AI models an incredibly efficient way to know when they're on the right track and, just as importantly, when they're not.
And this whole idea of an AI's instinct, it really gets to the heart of a huge puzzle in the field right now. I mean, we have these incredibly powerful models that can chew through super complex problems. We're talking advanced math, logic puzzles, you name it. But they have this one critical blind spot. They can spit out an answer without having any real clue if that answer is actually correct.
So, let's break this down with an analogy. Just think of a big language model as the smartest student in the class. It can write these brilliant, super detailed solutions. But hey, even the brightest kid in the room needs a teacher to check their homework, right? To make sure they're actually learning things the right way. Well, it's the exact same for AI. Now, for a while, the standard way we've been teaching these models is with a method called reinforcement learning with verifiable rewards, or RLVR for short. The idea is pretty simple. The AI tries to solve a problem, and if it nails the final answer, it gets a reward, like a little digital gold star. This whole process just encourages the model to get better and better at reasoning.
But here is the massive catch. This only works when we, the trainers, already have the answer key. It's fantastic for the training phase. That's like doing homework with a teacher looking over your shoulder. But when that AI is out in the wild, at test time, there is no answer key. The teacher's gone, and that smart student is left completely on its own, with no way to check its own work.
So to try and get around this, researchers came up with a couple of workarounds. But as you're about to see, these older methods were kind of like hiring a super expensive private tutor or making the student do all their homework twice. Both are really slow and really costly.
So these fixes basically came in two flavors. The first one was to build an external verifier. This means you train a second, often way bigger AI model, and its only job is to check the first model's answers. It works, but it's incredibly expensive. The second approach was sequential self-verification. Here, you ask the same AI to first solve the problem and then, as a totally separate step, write out this long critique of its own answer to figure out if it's right. It basically doubles the work and the cost. But what if there was a better way? A much, much smarter way? This is where the LaSeR paper just changes the whole game. The researchers had this massive breakthrough, finding a signal of the AI's own confidence that was, and I love this, hiding in plain sight the entire time. The huge insight, the real aha moment, was realizing that the model's own private assessment of its solution is already baked into its thinking right at the very end of its process. It's this super subtle signal, hidden in the probabilities of what it thinks it might say next, even after it's already finished talking.
And this led them to define something called the last token self-rewarding score. It sounds fancy, but it's basically a number for that gut feeling. Instead of some complicated process, the researchers pretty much just asked the model, okay, you gave me your answer. If you had to say just one more word, what's the probability you'd say the word correct? And it turns out a high probability for a special correctness token is a super reliable sign of high confidence.
This quote right here, this captures the core of the whole thing. The paper actually proves that under the right conditions, this gut feeling score is mathematically the same as the actual reward. A 1 for correct, a 0 for incorrect. This incredibly elegant connection is what makes the entire LaSeR method work. Okay, so you've got this powerful insight. How do you actually go about teaching an AI to develop this gut feeling? Well, it all comes down to a really clever process of calibrating its own instincts.
The LaSeR method is actually pretty simple. First, the model generates a solution, just like it always does. Second, we calculate that gut feeling score from that very last token. Third, and this is the key part, we compare that score to the real answer. Then we just use a simple training goal to nudge the model's score so it lines up better with reality. You do this over and over, and the AI just learns to produce scores that are a really accurate reflection of its own confidence.
And what makes this such a game changer is just how ridiculously efficient it is. LaSeR isn't some whole new way of training models, it's a simple, super lightweight add-on. You don't need that separate, expensive verifier model anymore. And the extra cost to your computer? It's almost nothing. It's basically the cost of having the model think about one single extra word after it's already done.
Of course, a cool idea is one thing, but you gotta see the results, right? And the experiments show LaSeR isn't just a neat theory. Our student, the AI model, doesn't just start getting better grades, it becomes an expert at critiquing its own homework. Okay, so first off, let's just look at raw performance. This table shows that just by adding LaSeR to a standard training method, you actually improve the model's reasoning. It goes from about 41.8% to 42.7%. That's a nice little boost, but honestly, that's not even the main event.
No. The real magic, the truly mind-blowing result, comes from the model's brand new ability to evaluate itself.
And this comparison, this is where things just get wild. On the left, we've got a 7 billion parameter model trained with LaSeR. Its ability to judge its own answers, its self-verification score, is 79.6. Now on the right, you have a specialized verifier model that is 10 times larger, a 72 billion parameter giant, and its score, it's 80.0. I mean, this is astounding. The little LaSeR model can critique itself almost as well as a gigantic, custom-built tutor, all at a tiny fraction of the cost.
So, what can you actually do with this powerful self-awareness? Well, one awesome application is improving how you pick the best answer. If you have the model generate a few different possible solutions to a problem, you can use its gut feeling score for each one to decide which answer you should trust the most.
And this chart shows you exactly why that's so important. On this math benchmark, if you just take the most common answer from a few tries, that's standard voting, you get 86% accuracy. But if you use those LaSeR scores to give more weight to the answers the model feels most confident about, the accuracy jumps up to 88%. Better self-awareness directly leads to better, more reliable answers. It's that simple.
So let's zoom out for a second and think about the big picture here. This isn't just about getting slightly better scores on math problems. This is a real step toward a whole new class of AI.
When you get right down to it, the payoff here is huge. LaSeR gives us more reliable AI that can actually tell us when it's not sure about something. It makes training these incredibly complex models way cheaper and more efficient. And that makes this advanced tech more accessible to everybody. And maybe most exciting of all, it's a huge step toward AIs that can genuinely self-correct and improve all on their own.
And that really leaves us with a final thought. This research shows that with one simple, elegant idea, we can start to give our AI tools a sense of self-awareness. So it really makes you wonder what new doors open up when our most powerful tools can not only do the work, but can also reliably tell us how well they're doing. The answer to that could honestly redefine the future of AI.